In this lesson, we are using order of operations to evaluate algebraic expressions, so that's going to be the learning intention. And remember, order of operations is PEMDAS, which you may have learned before. P stands for parentheses, E is exponents, and then M and D are multiply and divide, which you can do in either order, and then A and S are add and subtract, which also can be done in either order. So you want to make sure you follow the order of operations in each of these problems because it will affect your answer. Go to example 1, where we're going to evaluate an algebraic expression, which means see what it equals. And what we're going to be doing is plugging in the value given to us. And in this case, x is 6. So we are going to plug in a 6 anywhere we see an x. I'm going to rewrite the expression, but instead of an x, I'm going to put a 6. And again, the key here is that you use the order of operations because you can get multiple different answers depending on the order that you choose to evaluate this in. But the order of operations says to do parentheses first, which means we need to evaluate this part first. So 7 plus 5 parentheses, 6 minus 4 is 2 with an exponent of 3. So using PEMDAS, we've dealt with parentheses already. Next, it says to do exponents, which means that we have to be very careful. We cannot combine the 5 and the 2 first. We have to deal with the fact that the exponent of 3 is only on the 2. So do not try to say 10 to the third power. Be very careful with that. We've got 7 plus 5, and I'm still going to use parentheses, although you don't really have to. It just means multiply. 2 times 2 times 2 is 8. 2 to the third power is not the same as 2 times 3. So we've got 7 plus, we've done exponents, and now we're going to multiply 5 times 8. There's no division to do. So 5 times 8 is 40. Final answer, 47. For part B, there are 2 different variables that we're going to plug in for. We have x is -2, which will replace anywhere we see an x. And then y is 4, and we're going to also replace those. So I'm going to rewrite this, but instead of using my variables x and y, I'm going to plug in my -2 and my 4. So I've got 2 times -2 plus 4 on top. And then on bottom, x times y would be -2 times 4. And then we have -2 times x, which is -2. And oftentimes you're going to see parentheses just used to show that you're multiplying 2 things together so that you don't accidentally think you're adding or subtracting them together. So on top, we have 2 times -2 is -4 plus 4. On bottom, -2 times 4 is -8. And then we have -2 times -2. There are 2 negative signs right there. So 2 negatives are going to cancel into a positive. Think about it like -2 times -2. Positive. On top, you have -4 plus 4 is 0. And on bottom, -8 plus 4 is -4. But anytime 0 is on top of fraction, we equal 0. So in the next example, it gives you a word problem, and I'll read the word problem, but really it is just plugging in the same way we did in example 1. It says the bar graph in the figure shows the average cost of tuition and fees for public four-year colleges adjusted for inflation, and the formula is given below, which models the average cost of tuition and fees. So the capital T stands for what the average cost of tuition would be after however many years x. X is going to be the number of years after the year 2000. So for example, if I wanted to know the average cost of tuition in 2004, I would plug in 4 for x. The question says, to use the formula to find the average cost of tuition and fees at public U.S. colleges for the school year ending in 2010. So Since X is years after 2000 and we want 2010, all we have to do is subtract 2000. You already know by looking at it that X is 10 years after the year 2000. We're going to use this formula by just plugging in what we know X is going to be. I'm going to put a 10 in anywhere I see an X and use order of operations. So average tuition, capital T, is 4 times 10 squared plus 330 times 10 plus 3,310. Remember to do the exponents first. So I've got 4 times 100 plus 3,300 plus 3,310. And then just putting it all together, you're going to end up with average tuition in 2010 is $7,010. That is the estimated average tuition. For 2010. But the next part of the question says, by how much does the formula underestimate or overestimate the actual cost shown in the figure? Because you have to remember, formulas are there to help you predict things, but in reality, they don't always match identically. So we can see on this figure in 2010 what the actual cost was. And I'm going to go ahead and write it out here. Actual tuition was pretty close to our estimated. Actual tuition was $7,020. Estimated was $7,010. Since our estimated tuition is less than what actually happened, we underestimated. This is an underestimation of just find the difference between the two by subtracting. We underestimated by $10. And that's what the question asks. It says, by how much does the formula underestimate or overestimate the actual cost? And we underestimate by 10. Heading to example 3, we are going to simplify an algebraic expression. And when you see the word simplify, don't confuse it with the word solve. Simplify means combine like terms. That's all you do. You are not solving for X. So I'm actually going to just start off by rewriting the problem. Now that I've rewritten the problem, I do want to use order of operations so that I can combine my like terms, and I've got parentheses. And when you have parentheses, you typically want to get rid of them. In this case, you can get rid of your parentheses by just distributing what's on the outside of them. So I've got a positive 6 and a positive 10. This plus sign makes the 10 positive. If it were a minus sign, you'd have to distribute the negative with it. But they're both positive, and I'm distributing the 6 and the 10. I get 12x squared plus 24x plus 40x squared plus 30x. And I want to find my like terms because simplifying means combining like terms. X squared goes with x squared, and x to the first power goes with x to the first power. When you combine them, you don't change the x squared at all. You just change the number in front of it. 12x squared plus 40x squared is 52x squared. Again, don't make it x to the fourth power because that's multiplying, and that's not what we're doing here. We're just adding. For my x to the first power, I've got 24x plus 30x, and that is 24 plus 30, 54x, the first power. Don't change the power when you are adding or subtracting, and that's your final answer. If you take a look at B, it's very similar. You're going to do it, and you're going to check your answer on OneNote, and same with C and D. But be very careful because in part D, you see that you've got a negative sign and no number in front of parentheses. And so double check that one on OneNote, because when you have a negative sign in front of parentheses, you are subtracting all the terms inside the parentheses. That's going to change every sign. So just make sure you're aware of what a negative outside of your parentheses will do. Definitely go back to D to double check your answer, especially the signs. But I will do E because you see a different type of symbol. This is a bracket, not a parenthesis. But the truth is it's exactly the same. It's just that parentheses are already in use inside of the bracket. So it's just another way of making parentheses, honestly. I'm going to rewrite the problem. And what we want to do is work from the inside out. We want to get rid of parentheses, but start inside. So I'm going to focus on getting rid of these parentheses first. And what you do to get rid of them is you see, is there anything I can combine? The answer is no. And is there anything to distribute? But the answer for that is yes. There is a negative sign out front. So this negative sign affects everything inside the parentheses. So I'm going to rewrite. And what I want you to pay attention to is how the negative sign went to both the x and the 3, which means that x became negative and 3 became positive because it changes both signs. And once you've gotten rid of those parentheses, you can now look inside your brackets and see, is there anything I can simplify inside these brackets? Because again, we want to use order of operations, which means we have to deal with parentheses first. And I told you guys, think of these brackets like parentheses. So simplify what's inside. And these are my like terms inside. I've got a positive 5 and a positive 3. We want to be careful with our signs, because if you mess up the signs, you mess up the problem. Rewriting this whole thing, 5 plus 3 is 8, and then I still have that minus x right there. At that point, if you want to turn those into parentheses to feel better about yourself, you totally could. The most important thing is that you now distribute this positive 2 to each thing to get rid of it. Because again, it works the same way as parentheses do. You just distribute. I get 8x. Positive 2 times 8 is going to be plus 16. Positive 2 times negative x, that's going to be negative 2x. Final step, check one more time for like terms. Now that there's no parentheses, there's nothing else to distribute, you can add and subtract. And 8x minus 2x, 6x. So you are going to do the other problems and check them on OneNote. In class, I believe I do a few more of these for extra examples, so you definitely want to check and see if you're doing them correctly, and sometimes I'll show some work on OneNote for them. After that, the additional practice, you can find the answers for also on OneNote, and then make sure you put a summary in the box. And if you need help writing a summary, let me know.